So in this video, I'm going to go over the basics of scripting in Godot. For the purpose of this video, even though I'm working in the class RunJumper project, none of this is going to be related to the project. You just have to have, a project to work in. But I'm just going to be going over some of the fundamental basics of scripting, regardless of what you're actually trying to do. So to create a new script, you want to select a node in your node scene, such as main or player. I'm going to go to the player node. And then you click this little attach a new or existing script to the selected node. Technically, if you wanted to, you could also come down to your file system, right click somewhere, and add a new script. And that will just create the script. But in most cases, you're going to create a script by attaching it directly to a node. So we'll select our player node and we will click the attach new or existing script, and we will select either an existing script or a new script. And because of how I like to organize my projects, I'm going to go up to the root folder for my project, add a new folder called scripts, and we'll just add this new script in there. Now there's a few other options here. When creating the script, you can choose what it inherits from. By default, it's going to choose whatever node type you have selected. And so our player is a character body, so our script is going to inherit from character body 2D. You could change this to static body 2D, node 2D, node, resource. There's kind of whatever you want it to be, but it makes sense to just go with whatever thing you are attaching the script to. You can also choose from a couple of templates. There's the basic movement for a character body 2D. There's a default for a node. This is going to give you just some of the common functions that all scripts are likely to have, or an empty object. In this case, we're just going to go with no template, give us an empty script. And then we'll say create. So you can see in our script, the first thing to point out is at the very top it says extends character body 2D. So this is just letting you know that this script extends that class, the character body 2D class. I say class instead of node because a node is a class. A class is just a general term for a definition of a thing in your project. So this script extends character body 2D, which means that everything that character body 2D has, including its parent classes, which is collision object 2D, node 2D, canvas item, and node, we also have access to in our script. So for example, a character body 2D has a position because a node 2D has a position. So we can actually reference the position by typing the position property. So that's what the extends gives us. It gives us access to everything within that class and its parent classes. So the first thing we're going to talk about is variables. A variable is just something that can hold a value. And in GDScript, the keyword for creating a variable is var. So var means we are defining a new variable, and then we give it any name we want. I'm just going to call this x. And that's it. I have defined a new variable called x. GDScript is a loosely typed language or a dynamically typed language, which means that when you define variables, you don't have to tell the script or the engine what its type is. It could be an integer, it could be a string, it could be a node, it could be a sprite. It doesn't really matter at the time that you define it. Its type is going to come from whatever value you assign it. So if I say var x equals 10, it is now an integer, and it will be treated as an integer when I use the variable x in other places. If I gave it the value hello as a string, then it gets the type string because that's what a text string is. And so its type comes from whatever value you give it. And you can actually change its value, but you can change its type by changing its value later on in the code, but that's not really something that you're going to do a whole lot, so you don't kind of have to worry about it. Just know that the type comes from whatever value you assign it. Now, in some cases, you want to limit what types or what values can be assigned to a variable, in which case, after the variable name, you just give it a colon, and then you can explicitly specify the type. So I can say this x is an integer, which in code is just going to be int. It's shortcut. It's abbreviated or shortened because programmers are lazy. It's true. We don't like to type more than we have to. So now x is an integer, and I can only assign values that are integers to x. If I try to assign something else, then I'm going to get an error. So you can do this if you want to enforce that. And there are a few reasons why you would want to do that in some situations, which I'll get into later, but not now. Just know that you can do that. And you can even combine the two. So I can say my variable x is an integer and assign it the value of 0. Now you might wonder, like, why not just assign it value 0, which turns it into an integer? Again, there are cases where you want to explicitly limit its type to a specific type, in this case, integer. And so you might want to do both like that. So you can have all sorts of variables. You can name them whatever you want with a few exceptions. Variable names can only contain letters, numbers, and underscores. So I could name this x. I could call it x2. I could call it x position, if I can spell correctly, position. Those are all valid names. What you can't do is you cannot start the name with a number. So I can't call it 2x position. That's not valid. It cannot contain other special characters like ampersand. That's not ampersand, that's at. Ampersand, at. It can't include the hash symbol, bang symbol. None of those are valid characters to use in a name. You also can't use reserved names. Reserved names are things that already exist and are used for other things in the language. So for example, I could not create a variable called extends because extends is a keyword. It means you are extending some other type. I also can't name this variable func because that is a keyword for defining a function. I can't call it return because that is a keyword for returning from a function. So any keyword is off limits. But other than that, you can use whatever name you want as long as it's letters, numbers, and underscores. You can use upper and lowercase. So I could call this x underscore position with a, again, with a capital P instead of a lowercase p. All perfectly valid. So those are variables. They are things that hold values, and then you can use those values by using the variables. The next thing we're going to talk about is functions. Functions are crucial in programming languages. A function is just a block of code that you can call by using the function name. So for example, I might define a function using the keyword func called add. And I want this function to take 2 arguments. So I will pass those arguments in as a and b. And then you end the function definition with a colon. So that is a function definition. And then the body of the function determines what this function actually does. So I can define a new variable called c and assign it a value that is a plus b. And then I will return the variable c. So now if I want to call this function from another function, let's just create a function called foo. I can say var x equals add 2 and 5. And what's going to happen is this line is going to end up calling this function. It's going to pass it these values, 2 and 5. The variable a, or the argument a, is going to get the value 2, and the argument b is going to get the value 5. And so on this line, the variable c is going to get assigned the value 2 plus 5. But only in this instance because I'm calling it with the values 2 plus 5. I could also say x equals add -6 and 17. And so now when this function is called, the variables a and b will have the values -6 and 17. So you call a function by using the function name. If it takes any arguments, you pass those arguments in, and then the function will do whatever the code in the function says to do using the arguments, if any, that get passed in. So it's very useful for doing the same thing over and over, or being able to create a block of code that can then be used in other places without having to copy that same code over and over. So add is a very simple example because we could just say here x equals 2 plus 5. But if you can imagine the function does something more complicated, it would be a lot easier to just call the function name here rather than copying that more complex code everywhere. Something important to note about functions is GDScript is, what's the term? It's a indentation aware language, which means that your indentation level determines what code is part of the function. So you notice my function definition is all the way on the left side of the window, but the body of the function is all indented one line. If I were to do my return statement like this without the indentation, you can see it got highlighted red, and down at the bottom it says unexpected return in class body. It does not treat this line as if it were part of the function because the indentation doesn't match the indentation of the rest of the function. So it's an indentation aware language, which means that the body of functions, of conditions, of loops, of anything like that is determined by the indentation level. There's no special keywords or symbols that are used to represent the beginning or end of a function like in other languages. It's based purely off the indentation. So very important to keep that in mind for your functions and conditions and other things. Speaking of conditions, let's talk about conditions next. So a condition or a conditional statement is something that is going to check the value of something else, something that can resolve to either a true or a false statement, and then it's going to execute some block of code based on whether that expression is true or not. So for example, if I do x equals add 2 and 5, after this I could do something like if x is greater than 0, print x is positive, else print x is negative. So I've got two different print statements here, x is positive and x is negative, and which one gets called is going to depend on the condition that I'm specifying here if x is greater than 0. So if x is greater than 0, which it should be because 2 plus 5 is 7, then it will execute this line. If this statement is false, then it will skip this line and go down to the else condition and execute that code instead. Now, the else is completely optional. I could just leave that out, and then it will only execute this code if the condition is true. If it's not true, it won't do anything. It'll just skip over the indented block of code after the if and go to the next code. So let's actually put this into practice. Instead of foo, I'm going to create a function called _ready. And this is a built-in function that GDScript looks for on nodes. If I mouse over this, you can see the documentation says called when the node is ready, i.e. when both the node and its children have entered the scene tree. So this is a function that you can optionally define in any of your scripts, and if it exists, then Godot will call it essentially when your node is first created, when it's first added to the scene. It's kind of an initialization, get ready to do something sort of function. Important to note here, it starts with an underscore. All of the kind of built-in special functions that Godot provides are going to start with an underscore. So if you don't name any of your functions in a way that starts with an underscore, it'll be easy to tell which ones come from Godot and which ones you defined on your own. So I'm going to add this function called ready. We're going to leave this the same, and I'll add my else condition back in. We'll say x is negative, and then afterwards I'm going to do another print statement and say this comes after the conditional. Whoops, don't know what that was. Pressed the wrong key somewhere. Okay, so let's actually run this. And what happens in the game window is not important. What we want to look at is this output window. So this is where the print statements will occur. And you can see it printed x is positive, and this comes after the conditional. So our code evaluated this expression if x is greater than 0, determined it was true, and so it executed this code that came right after it. And it skipped over this code because this is only going to happen if the condition is false. And then this next line happens regardless because of the indentation level. So because this print statement's indented, it's part of the true condition. And then because this statement's indented, it's part of the else condition. And because the indentation returns back to the original level, this is not part of either condition. So let's try a different thing here. Let's say add 2 and -5. Now if we run this, we should get a negative value, and we can see the statement x is negative gets printed to the output window. But we still see this comes after the conditional because it's not part of the condition. Doesn't matter if this is true or false, this is going to get called regardless. So conditional statements are very, very important. They're going to be used a lot in your code to check for different conditions, like if a button is being pressed, or if the player's health reaches 0, if you collide with another object. These are all situations where you need a conditional statement to check to see, is something true? And if so, do something else in response to it. So these are kind of the core building blocks of any script that you write. Your variables, your functions, your conditional statements. Obviously, there's a lot more that you can do in coding. There's different types of loops. There's new class types that you can define. There's all sorts of stuff you can do. But this is the very basic fundamental building blocks of scripting. Your variables, your functions, your conditionals. So let's wrap this up with a little bit more of a Godot specific example. So my variable C that I define up here, the scope of this, the lifetime of this variable is limited to this function. So after this function returns, this variable C no longer exists. It's defined in the function, it's limited to the function, which means I could actually do something down here like say var C equals -x. I can define a completely different variable C because it's in a different function. However, if I define a variable outside of a function, like this is called a class variable. It's not limited to the scope of any function within this class. It exists outside the functions. It exists within the scope of the class itself. And now I can reference this variable anywhere else in my script. So I can say, health equals health plus x. And it's going to update the value of this variable within this function because it's a class variable. I can use it in any function within this class, my player class. Now, what I just did here, this is a very, very common situation you're going to run into where you want to increase or decrease the existing value of a variable. And like I said before, programmers are lazy. We don't want to type more than we have to. So there's a shortcut for this, and you can just say health plus equals x. That's going to add the value of x to the current value of health. If I just did health plus x, it's going to add the two values together and return it, but I'm not doing anything with the results, so it's just going to kind of disappear. But if I say health plus equals x, it will add the value of x to the value of health and assign that value back to the variable health. You could also do minus equals, you can do times equals, divide equals. All of these are perfectly valid operators. So because health is a class variable, I can use it anywhere in the class. And I said we're going to get Godot specific. Here's something specific about Godot. Because this is a script for my player object up here, this is something that I might want to either see or perhaps even edit in the inspector without having to come back into my script. So to do that, I can add this special keyword in front of my variable declaration using the @ symbol and then export. So this is now an exported variable, and we can see that it now appears over in the inspector window. And we can see a new variable under player.gd called health, and I can assign any integer value to this because I gave it a type int. So I said at the beginning, there are situations where you want to, it will be useful to explicitly set the type for a variable. This is that situation. If you're creating export variables in your script because you want to use them in the inspector, you need to define what the type is. What values can I assign this in the inspector? Otherwise, the inspector doesn't know, should this be an integer box, a text box? Is it something that I can let the user drag a texture onto? How do I edit this thing? So you need to give it a type. You can still assign it a default value. So I could say health equals 5, and then we can see the inspector updates. But now I can assign this. Let's come down here to our ready function, and let's get rid of all of this. And I'm going to print out the initial health. So health equals, and then if I want to print the health in this print function, it needs to be a string. So I'm going to pass it to this str function. And what this function does is it's a helpful little built-in function that converts any value you pass into it into a string. So what we should see now on the console is health equals 5. If in the inspector I change this to 10 and run it again, now we can, I did not save it, sorry. You got to actually like click off or do something so that it accepts the new value. So now if I run this, we can see, nope, still says health equals 5. What am I doing? This is the fun of trying to program live, even though it's a video. That might, oh, some of you probably spotted this before I did. I'm passing 5 to that string function. It's not health. So I was literally printing the value 5 instead of the value in my health variable. And because I'm such an honest person, I'm going to leave that in the video instead of editing it. So now we can see health equals 10. If I change this to 15, health equals 15. So notice I'm not editing my script each time. I'm just changing the value in the inspector, and because it is an export variable, it will get the value from the inspector that'll overwrite whatever value I specify here. And this can actually change at runtime. So another handy function that you will use a lot in your scripting is process. And this is going to get called every single render frame. So if I mouse over that, we can see called on each idle frame prior to rendering. So this is going to get called just before the scene gets rendered. And this is where you can do any updates. You can check to see, is it still alive? Did I hit something? Has my health increased, decreased? Do I need to move? Stuff like that. And so let's just copy and paste this line from ready into the process function. Now we're going to see this kind of spam through the console because it's getting called every single frame. But as I update this in the inspector, you can see it updates in real time down the output window. So health is now 25, health is now 17, health is now 5. And so I'm not having to change my script. It's something I can change at runtime through the inspector. And that's because of this export keyword. So this is going to be very, very useful. Not all of your class variables need to be export variables. Maybe we have like a max health, and maybe we set that to 15. And then we have a current health equals max health. And so maybe this is something that for each player we can assign a different max health, and we want to be able to edit that in the inspector. I was complaining because I changed my variable names. So we might want to be able to configure the max health for each player in the inspector, but then the current health, that's going to be based on, you've taken damage, you've healed, or whatever. And so maybe we don't need that to be public or like exported. It's something that we edit in the inspector. It's just something that we need to be able to use throughout the class. So those are our export variables and our class variables. The last thing that I'm going to cover in this video is being able to access and use child nodes within your script. So this script exists on the player node, and within the player node, I might want to access my animated sprite 2D and change which animation is playing. So the way I can do that is by doing $, and then the name of the node, animated sprite 2D. So this is going to reference the child of whatever node the script is on. It's going to get the child node called animated sprite 2D. And now I can do something like call play and give it the run bottom animation. Let's get rid of this process function, and we'll run that. And now we can see our players running because I played that animation in the ready function. Let's try run top. Now that animation is going to start playing. So that's how you can access child nodes within your script. And one thing that's really nice about Godot is if you don't want to type all this out, you can literally just click and drag the node from the scene hierarchy into your script, and it will add the node name. So that can be really nice. One thing to keep in mind, it is based off the name of your node. Even though the name initially is just the node type. If I were to rename this to animation, it's not going to update my script, but now this isn't going to work. We can see if I run this, it's going to give me an error and say attempted to call function play in base null instance of null instance. So it's basically saying this thing doesn't exist. So I would need to change this to say animation, and now it should work. So very important to remember, whenever you reference a child node using this $ notation, you are using the name of the node. And so whatever the name happens to be, if you change the name, you need to make sure you update your scripts as well. So that's going to cover it for the basics of scripting in Godot. Like I said, this isn't necessarily related to our RunJumper project, even though I was working within that project. This is just general scripting for any project in Godot. And then in the next video, we'll come in and actually start defining the scripting for our player character.